The braking of a vehicle, its reaction during deceleration and stopping distances all depend essentially on the friction between the tires and the road surface. The best possible braking action, therefore, is that which further exploits the road-holding potential in every condition, without the wheels locking. It is a well-known fact that, besides prolonging stopping distances, wheel locking leads to very dangerous situations, such as loss of steering control if the front wheels lock, and complete spin skid if the rear wheels lock. This is the case when the road surface is wet or iced over, or when the driver, confronted by unexpected obstacles, instinctively presses the brake down hard, panic-stricken. In these conditions, the overwhelming element of surprise causes the majority of drivers, even a capable, controlled one, to lose his capacity of efficacious reaction. The only solution in these situations is to have at one's disposal a braking system which enables the holding potentially available for each wheel to be utilized independently to the greatest possible degree and without causing the wheels to lock. From this has sprung the idea of the ABS Mark II anti-locking system by Alfred Teves. We have witnessed a test of comparison between two cars, one having a traditional braking system, the other equipped with the ABS system. The car equipped with the ABS Mark II system clearly demonstrated perfect steering control and an obvious reduction in stopping distances. Moreover, the wheels were not allowed to lock. The trial was carried out in identical conditions of speed and road surface with the same excess of pressure applied to the brake. The ABS Mark II system prevents the four wheels from locking and improves stopping distances, at the same time conserving steering control, which is a basic necessity when faced by hazardous situations. This control system has been applied to hydraulic systems which tend to be close relations as far as the philosophy, weight and dimensions are concerned to the traditional ones. The result constitutes one of the most important safety devices on certain models of Alfa Romeo cars. Furthermore, the introduction of special adjustment techniques aided by a microprocessor logic more than satisfies the greatest expectations of car safety and handling, whatever the braking action or road surface condition. The ABS Mark II system comprises a hydraulic unit, a pump assembly, an electronic control unit, and conductive sensors. The braking system is divided into 3 hydraulic circuits, 2 of which are for the independent control of the front wheels, the remaining one for the rear wheels. During a braking action in normal conditions, the ABS Mark II reacts like a normal hydraulic servo brake. That is to say, it invigilates but does not intervene. The driver is therefore able to modulate the pressure, as on the normal braking system, thus attaining the desired deceleration. Let us now consider the system's main components. Pump assembly. This comprises a pump activated by an electronic motor which keeps the brake fluid in the storage tank at a value of between 140 and 180 bar. This is a pressostat with 3 microswitches, each activated at different pressure values. One of them energizes the electric pump control circuit when the pressure goes below 140 bar. The other 2 are activated at 105 bar, thus supplying an alarm signal to both the electronic control unit and the Alfa Romeo control. Hydraulic unit. This features a servo brake, which functions with the brake fluid pressure, and a hydraulic assembly made up of 3 pairs of electrovalves. One of each pair is for loading another for relief. When appropriately controlled by the control unit, the latter determine the braking pressure in each of the 3 hydraulic circuits during ABS adjusting action. There is also a main electrovalve, which enables the static circuit to be connected to the dynamic one during ABS adjustment, dealt with later on. Inductive sensors. The inductive sensors are assembled 1 on each wheel and register the speed of the latter by means of a phonic wheel system. They send the control unit a signal having frequency and amplitude proportional to the magnetic field variations generated by the transit of the phonic wheel teeth. It should be noted that the signal is also affected by the air gap between the sensor and the tooth. In this respect, Alfa Romeo cars do not anticipate any adjustment inasmuch as the head of the new sensor already features a plastic coating which enables it to drive fully home. Electronic control unit. The electronic control unit represents the intelligent unit of the ABS Mark II system. It receives and processes signals from 4 sensors and controls the electrovalves of 1 or several wheels tending to lock. The control unit contains 2 perfectly identical circuits, each one handled by a microprocessor. The 2 microprocessors process the input data separately and compare the output data between them, giving the commands only when the data is consistent. This type of system, known as redundant logic, permits absolute operational safety, as indeed is required of a braking system. Let us now examine the operation of the ABS Mark II system when the wheels tend to lock. Pressing the brake pedal activates the linkage, which enables the fluid under pressure in the storage tank to flow into the dynamic circuit. The fluid then flows to the rear wheels by means of the loading electrovalve. The linkage also moves the brake pump piston, which is servo-assisted by the pressure in the dynamic circuit. The static circuit, which is connected to the rear wheels by means of the loading electrovalves, is thus activated. Take, for example, a front wheel tending to lock. The corresponding loading electrovalve is closed. At the same time, the control unit opens the main electrovalve, connecting the static and dynamic circuit. Subsequently, the brake pedal positioning bushing moves back, this motion being scarcely perceived by the driver. So, even in the event of a hydraulic breakdown, the volume of brake fluid is sufficient to terminate braking. The control unit now controls the relief electrovalve of the wheel tending to lock until the wheel acquires once again the speed established by the control unit. At this point, the relief electrovalve closes and the corresponding loading one opens at brief intervals until the tendency of the wheel to lock reoccurs. The cycle is repeated until the braking action is over or the vehicle has stopped. The example given is applicable to all three hydraulic circuits, the sole difference being that the rear axle circuit is for both wheels. Here, adjustment is carried out according to the select low principle. In actual fact, the control unit processes the signals coming in from the two wheels separately, but it adjusts both of them according to the one that is locking. We have thus dealt with the operation of the ABS Mark II system adjustment. Let us now examine what the driver has at his or her disposal to check good or poor system operation. Turning the key to the run position causes the AS warning light on the cluster to illuminate. This verifies its operation. Meanwhile, the control unit carries out a diagnosis of its own condition and that of connecting components. If the warning light extinguishes after a few seconds, system efficiency is confirmed. The procedure described is repeated once again when the key is returned to the run position from the start position. Further dynamic testing on the sensors, brake fluid pressure and electrovalves is carried out while the car is running. The driver will be informed of any failure by means of AS light illumination, which reports the following situations. If the failure is not such as to affect the entire system, ABS adjustment is partially excluded. An example consists in the breakage of a sensor or electrovalve of the front axle, which leads to the exclusion of the front axle but not the rear one. If, on the other hand, the failure affects the entire system or jeopardizes safety when braking, ABS adjustment is fully excluded. For example, if brake fluid level or pressure decreases to excess, or in the event of a failure at a sensor or electrovalve of the rear axle. If the failure has occurred temporarily, the ABS adjustment is automatically reactivated as soon as the failure ceases to exist. An example of this could be the inconsistency in the data supplied by the sensors subsequent to momentary electromagnetic interference. It is reiterated that whatever the type of ABS adjustment exclusion, the braking system behaves like a normal servo-assisted system. Besides the yellow warning light, Alfa Romeo cars also feature Alfa Romeo Control, which provides an additional indication of failure in the braking system. For example, if the brake fluid level goes below the minimum level, the alarm signal is given. If the fluid level decreases further, the AS warning light illuminates besides the Alfa Romeo Control one, as a dangerous situation has arisen. Furthermore, the Alfa Romeo Control warning light also illuminates together with the AS one when the storage tank pressure goes under 105 bar. In this case, the driver is informed that he still has a few servo-assisted braking actions at his disposal, after which the excessively low pressure can no longer assure braking system servo assistance. The driver of a vehicle equipped with the ABS Mark II system should never run unjustifiable risks, even if the system is designed to operate with absolute safety in the worst of conditions.